and welcome to the AlphaCam 2020 What's New videos. In this short video, we're going to be discussing the improvements we've made to our post-processing engine. It is known that AlphaCam has one of the most flexible and complete post-processing engines in the market. However, we have improved our post-processing engine so that we can drive a simulation session directly from within the engine. Now, what does this actually mean? Well, there's a number of benefits that users all over the world are going to be able to derive, but some of the key benefits that jump to mind are accurate simulation of rapids, accurate simulation of axis of rotation. In other words, you're going to see that there is a direct correlation between the post data, the X, Y, Z numbers, ABC numbers, and the simulation session, because it is the same engine that is driving both of them. Another benefit that immediately jumps to mind is the ability to simulate things that we in the past possibly ignored, such as an M6 tool change cycle or any other custom piece of hardware that you may require simulation on. The fact that we can now drive your post processor and your simulator with the same engine truly opens up a world of possibilities. We're very excited about this enhancement, so let's review the functionality. So we are now inside of AlphaCam, and you can see that I have a simple 3+2 5-axis machining project. I'm going to trigger the simulator, and you'll see that this in turn triggers the post processor. Now, AlphaCam has always been able to generate compelling user interfaces for our posts. And this is one of the things that I want to bring up right now. You'll notice that the post writer has given me, the user, the ability to put a number here for the work plane safe cancel level. Let's see what happens when I post that. You will see that now the simulator is then configured and deployed, and we'll be able to take a look at exactly what is happening based on the different variables in the post. So when I run my simulation, you'll see that the tool approaches, goes down, and here we go. There is a collision that has been identified based on that safe rapid level. Basically, it's too little. Given the geometry and size of this head, I need to separate myself, I don't know, a couple of 100 millimeters so that I can clear the bottom of the head. So let's try that again. I'm going to close, and I'm going to send to the simulator, but this time I'm going to change my work plane cancellation level to say 200 millimeters. And I'm going to go ahead and, just like before, the post processor will configure and deploy a simulator session, and we'll be able to run it. So now you can see how the tool is going to approach and begin machining the different motions, the different operations. Now, we've always done exactly this, where the tool change cycle is not necessarily something that is included in the simulator. The tool simply is loaded onto the spindle and the additional machining moves forward. But now, the post-processor engine will allow us to deploy things such as simulate tool changes. Let's take a look at that simple option in the post-processor, what it can actually do for my simulator session. We'll have the approach just as before, and we'll have the transition between the planes just as before, at a 200 millimeter safety level above the different planes. But now the tool change motion is going to be given by the motion prescribed in the post processor. So I will be able to simulate my machine tool going all the way down, inserting, retrieving the tool, and continuing the work. This is important because A, it impacts your overall cycle depending on the location of your tool changer. The times may be different. And B, because we want to check collision between that tool and any part of the tool changer. So you can see now that the operation is continuing, and the second operation is basically identical to the first one. It's just doing it with a different tool, a finishing tool, if you will. All right, so you've seen some of the advantages of being able to drive the simulator directly with the data coming from the post. But there's also very exciting possibilities. As an example, I want to show you something that I included in this post processor. Parabolic workplane transitions. What do I mean by that? I wrote a simple algorithm that allows you to control the way you're going to be moving from one workplane to another. This is best viewed from the right view. So let me show you. You'll see that the tool approaches, the TCP is activating, and we're going to do the first machining here. But when we're done, there you go. I am creating a parabolic arc that basically goes to that point, and that point is precisely 200 millimeters. And we can use that point for the safety transition of the tool. Now, if I'm going to be doing that with the tool, arguably then I wouldn't need 200 millimeter clearance. I could possibly go back to the 50 millimeters that are originally required. So let's take a look at what that looks like once we run it in the simulator. So once again, I'm going to take a look at my right view. I'm going to run the simulator. I'm going to speed it up a little bit. Okay, here we go. So here's the machining of the feature. And there you go. Parabolic arc going from one workplane to the other, completely under your control, fully simulatable. The impact of those choices in the post are directly impacting the simulation, which is giving you honest feedback on what's going to happen. This is absolutely an industry first and an AlphaCam productivity enhancement. So please contact your reseller at your earliest convenience so that you may take advantage of this amazing feature.